everyone. My name is Claire Niederberger, and today I'm going to be talking to you all about random numbers, which is a topic that is very deep, and I hope that by the end of this presentation, you have an appreciation of just how much goes into getting your random number when you want to generate one. There's quite a bit. So, say you need to generate a sequence of random numbers that can't be predicted by chance, or a random number. Maybe you need this for cryptography. A lot of people use it for cryptography, or maybe you need it for gambling, or statistical sampling, or simulation, or maybe I want to set up my own lottery and force you guys all to use it. You would need a random number. So, just how do you go about getting it? Well, a place you could start is in nature. Random numbers that come from nature are true random numbers, and the only real random events that we know of as mankind right now are acts of God, if you believe in that kind of stuff. So this is referred to as true entropy, and it's really slow because you have to go out and harvest these events. So an example of a true random event is the specific amount of time between two lightning strikes. And that's not really practical if you're generating a random number in JavaScript, because then you have to sit there and wait for two lightning strikes to happen. And that means that you have to wait for a thunderstorm. So there are other sources that people can more readily harvest, but it's still slow. One of those sources is radioactive decay. So the time between two decay events is relatively random. But that's also wholly impractical for JavaScript, and it makes me a little nervous, and I don't want to subject you guys to radioactivity. So there are some other considerations to take into account. There's a big debate about which source of randomness is the most random, because there are a lot of different natural events that people are out there measuring. So there are quantum random events, and quantum theory describes the universe on atomic and subatomic levels. And there are random number generators out there that use the space between specific subatomic particle movements under certain special circumstances. So we don't know what specifically causes these events. So proponents of quantum randomness assume that it's non-deterministic, which is to say that they don't know if we'll ever be able to figure out if these events follow a particular pattern tied to the Big Bang. So even if they did, they say, proponents of quantum randomness say, well, it's kind of a pain to figure out everything that happened since the Big Bang until now that would cause these two specific random events to happen next to each other. So this is a really good source of true random numbers. But then there are people out there who say, well, you know, feasibly, we could figure that out. And they think that entropic randomness would be a more suitable, non-predictable set of random events to generate random, non-predictable numbers from. So an example of entropic randomness is weather patterns, so something like the lightning strike I was talking about earlier. And you could still feasibly predict it if you wanted to sit around and model weather patterns all the time. But strong proponents of entropic randomness say, well, that's a whole lot less of a pain than figuring out everything that happened since the Big Bang. So depending on which camp you fall into, and usually you fall into these camps if you're a physics person, depends on which you think would be harder to model or which you think we won't end up modeling. Because if you do end up modeling one of these things and you have a whole random system predicated on it, then things will tend to break. So we don't have really time to ponder whether everything's deterministic right now over the course of these 10 minutes. So what I've gone ahead to do to model generating a random number with a true random number generator is to just ping a source that measures that nuclear decay that makes me nervous that we were talking about earlier. So the nice people at Hotbits over here measure the time between radioactive events. They store it in a database. When you ping their route, They serve up to you one number, that's the time between two events, delete it from their database. As the events continue to happen, they continue to add them to the database, and as people continue to hit the Hotbits website, they continue to get deleted. So your random number will never be stored. So this is a way to get a random number. It's super slow. And the way that I got into JavaScript was with some good old-fashioned web scraping. So I just go and I ping the Hotbits website. Yeah, it's a great idea. So yeah, anyone can go and they can just ping the Hotbits website. They can scrape for that number, and then they can get a random hexadecimal number. And to do a little conversion, just because of how they, or a random decimal number. I had to do a little conversion just because he serves it up in hexadecimal numbers, and I figured it might be easier to use in decimal, but it will serve it up to you. So that bottom one, yeah, that one on the bottom right there is our web scrape random number, which is, a little slow. But yeah, you have the output of the time between radioactive events right there, which is kind of cool, and it's truly random. So then I was thinking to myself, as you do, well, what if I wanted to do this in a closed vacuum where I don't have to talk to anybody or communicate with the outside world? And these are some gummy randoms, which is a candy in England. And so that's like kind of the nerd's dream, right? So in this case, I'm going to need a seed, which is an initial source for my algorithm, whatever that algorithm is going to turn out to be, to do its thing. And this algorithm is basically going to generate numbers that feel approximately random. Since it's not a truly random number, it's called a pseudo-random number. You can still seed it with an entropic event from nature, but since you don't have to sit around and wait for those lightning strikes, it's a whole lot faster, and there are plenty of different algorithms you can choose from, and it all really depends on your output of which algorithm works best. So the Mersenne twister, the linear congruential generator, or the middle square method. There are people who, these two math PhD students, unfortunately the website's not up right now, but they took a lava lamp, they took pictures of the lava lamp, picked data from those pictures at random, and then used a scrambling algorithm to generate random numbers from a lava lamp. So you could even do that. And they used the lava lamp as their seed. So what I did was I emailed my statistician, and he said that for the purposes of this talk, which is very, brief, a good trick to create a normally distributed random number is to pick a number at random from the interval of -1/2 to 1/2, do it 12 times, and then sum it up. And it will basically spit out random numbers that fall along a bell curve. So I wondered, well, how does JavaScript pick those seed numbers? And the way that JavaScript picks those seed numbers is that it takes the last two numbers from your CPU's nanoseconds, which are essentially meaningless if you're pinging this thing and it's the last two numbers. And so it seeds it with those, and those are approximately randomly distributed, which is to say that they sort of fall along a flat distribution. But since I want my random numbers to come out on a bell curve, like let's say you rolled a dice a couple of times, I plug it into the formula that my statistician friend gave me, and out comes those random numbers. So here we have the algorithm for that, which is relatively simple. And first we just generate an array of 12 random numbers, and I get the last two numbers from my CPU's nanoseconds. I generate an array of those. I then convert them to the range that I need, and then sum up those values, and here you go. So I can send this all out to you guys too if you want some random numbers distributed. And it runs, and the guy at the bottom is our pseudo-random number. And you can see that when I run this, it happens a lot faster, the pseudo-random number, than my hotbits web scraping random number. That's just because it's web scraping, but you can imagine that waiting for radioactive decay events would take a long time. So hopefully I have given you guys a good insight into just how many different universes, fields go into getting something sort of random. And yeah, maybe when you use your random number function in JavaScript, you'll have a little more appreciation.